Okay, we're going to take a look at intersecting circles. So we're going to read this question here, and then we're going to establish a couple rules about circles. So if the following equation were graphed in the standard xy coordinate plane, which graph would not intersect the graph of x minus 2 squared plus y plus 1 squared equals 16? So this here is the equation of a circle, hence why the diagram over here. And we need to figure out which of these does not intersect it. So we need to kind of establish the rule of circles. And a circle with the center at the origin, which is kind of drawn here, would be written like this: x squared plus y squared is equal to r squared. And r is essentially the distance of the radius, so the distance from the center of the circle to anywhere around the circumference, the edge of the circle. And then these are some variables that would translate or transform the circle. So the k value here would do horizontal stretches or compressions, and the h value here will move the circle horizontally, so left and right. The a value here will do vertical stretches or compressions, and the d value here will move the entire circle vertically, either up or down. Okay? And again, radius, and I should put it still technically squared there, is equal to r squared. Okay? So we've established some of these rules. So what we need to do is kind of get an idea of what this circle is here. So the key thing here is we take a look. This is 16. So to find out the radius, we actually have to find the square root of that value. So if we square root 16, we're going to get 4. So our radius of whatever circle we're working with is 4. Okay? And if we notice, the circle's been moved. Okay? Hasn't been stretched or compressed, but it's been moved left and right and up and down. And it's actually the opposite of whatever the numeric value is within the bracket. So if it's -2, it's actually moved in a positive direction too. So assuming this is at the origin, this circle here, it's then been moved. Can I grab it? Yeah. It's been moved 2 units, so the center is there. And if it says up 1, then it's actually been moved down 1. And it has a radius of 4. So we'll have to expand that circle just a little. And like we said, we need to technically expand the radius of this. So it obviously needs to get significantly bigger. Assuming this is at the origin again, that would be 2, 3, it's probably closer to 4, roughly about there. That's at the origin. So that's the size of it. And then like we said, we moved over 1, 2, and then down 1. So our circle looks like it's something around here. So let's actually use a graphing calculator so we get a little more exact with what we're doing. So when we take a look, here's our circle centered around the origin. So we've pointed that out. It's the red circle here. And then here is our circle that is kind of will get moved around. So we have an a of 1, a k of 1, so it hasn't been stretched or compressed. The h is 1, so you'll see it's moved to the right 1 unit, and the d is 1, so it's moved up 1 unit. Now, those are positive values, and you're thinking you just said the opposite. But if I were to put 1 in here, it'd be -1 and -1 because the equation actually used negatives within that bracket. Okay? So now that we've established that, here is our actual circle, the blue one there. So I'm going to turn these two off. Okay, so here's our circle. And now that we see it, we can kind of get an idea of what the other graphs are. So our other graph, our first one is y equals x, which is essentially a line that kind of just cuts right through the origin. So this clearly intersects, and we're going to draw it out so that you can see it. We have y equals x, clearly cuts through. That's not the equation, that does not cut through. Y equals -x is the same thing, just sloped the other way. We'll take a look at it. Y equals -x, clearly cuts through that circle again. So that's not the equation we want. Y equals x squared is a parabola at the origin. So it's going to, again, cut through because we know this circle touches the origin. Just to prove it, we'll use it here. Y equals x squared. Yep, cuts through. And then this circle here. So here we are. We're getting into essentially 2 sets of circles, in which we were working with before. Now, if we take a look, I'm going to use a little deduction here. I want to work with this one because it looks like it's going to be a little simpler to start with. If you notice, the center of the circle is going to be the same, and our radius is smaller than before. In fact, the root of 9 of this version here, root 9, would be a radius of 3. So if the circle has the same center and the radius is smaller, then we clearly have a circle within our original circle, which would be much smaller. So I'm going to copy this equation since it's the same one as above. And the only difference is 9, and lo and behold, there's our circle. It's within. So it's definitely this equation here, but let's not, so it's definitely this one here, but let's go about drawing this. Now, this one only has a radius of 1, so it looks like it's going to be an extremely small circle. But we have the origins at the same spot, but we have some serious stretches and compressions. So let's take a look at what that looks like. So again, the equation is roughly the same, like we said, 1, but it had a horizontal 4, and it had a horizontal stretch by a factor of 4 here. And if you notice, when I take that away, here it is, and then when we divide it by 4, so you'll notice I'm going to draw the parameters around this one here, just so you have an idea. Here's kind of where the horizontal parts are stopping. Okay, let's go back, and when I put this to divided by 4, you've noticed it's been stretched much wider than it was before. Okay, so that's important to know. Along with that, we have another a vertical stretch. This one, we have 1, and I'll put the parameters again on this equation. Okay. Vertically, this is technically the circle, but as soon as we go ahead and vertically stretch it, after 36, boom, way farther than what it took before, and clearly intersecting our blue one. So this actually ends up being more of an ellipse than it is a circle. So keep that in mind when you stretch a circle. If it's not the equal radius all the way around, it is technically no longer a circle. Okay, so in that case, the red one is not the equation we're looking for, and it's the black circle that is going to be the one that works out for us.